All right, the door's closing. It's being locked. Welcome to the Thunderdome. No, I'm just kidding. Yeah, so last session of the last day of the conference, right? And I'm here to entertain you for at least 45 minutes. If you fall asleep, I'll be very sad. I'll just be depressed forever. No, but welcome to my session, my last session of the day, which is Goodbye Client-Side JavaScript, Hello C-Sharp's Blazor. Now, before I go ahead and get started, by show of hands, who here has heard of Blazor before? Oh, wow. All right. Cool. How many people are using Blazor today? Okay, a couple. It makes sense why you might not be using it today. But what I'm going to do in today's session is essentially dive into what Blazor is, jump into Visual Studio, show you some cool stuff within Blazor. Then I'm also going to talk a little bit about what we are doing at Progress with some UI components for Blazor. So that's exciting. Some of you might have seen me in earlier talks, and I've kind of alluded to this a little bit. The shirt that I'm wearing today that says Blazor and has ye olde power glove on it has sparked a lot of conversations walking up and down the hall. So Blazor's been a hot topic today. I think it's mostly because of the shirt, but I think this session is also very exciting, which I think is why they saved it for last. You know, this is really just to have everybody leaving here saying, Blazor, that's it, I'm doing it today. But just as a quick little introduction, if I actually turn this little thingy on here. So my name is Carl Bergenham, and I head up, well, I shouldn't say head up product development, but I am the product manager for all web components within the Telerik stack. So jQuery, Angular, React, Vue, Blazor, MVC, ASP.NET Core, ASP.NET Ajax. I'm your man for that. So that's what brings me here today. Now, I have a little scenario for you. What if client-side web, instead of JavaScript, what if it was C#? Isn't that kind of interesting, right? We've been dealing with JavaScript for so many years now. Now, I love JavaScript. I switched from majorly working within C# over to JavaScript. I love it. Doesn't yell at me all the time, except if I do Angular development, yells at me a lot. I mess up constantly, but I have other ways of preferring to know that rather than Visual Studio yelling at me, for example. But that's just my weird reason for liking JavaScript. A lot of people prefer C#. In fact, TypeScript, and I've made this joke earlier today, but TypeScript, I believe, only exists because C# developers hated JavaScript so much that they tried to make JavaScript look like C#. I think that's the whole reason why it exists. Now, it's a great programming language, and it works well, and now having something strongly typed within the web world, I think, ultimately works out well, but that's kind of how I think it started. That's really what I think ultimately is the reason why we have TypeScript to begin with. Now, some previous attempts that we've had into bringing C# over into the client side and essentially allowing that to be what we run on the client. The first attempt was really web forms. If we think about it, for the folks who have used web forms or ASP.NET Ajax, the idea was that anything that you can do with a component within web forms, you could do on the server side. Any requests, any interaction, anything that you did, any event was handled or could be handled on the server. So really, the first attempt at trying to have C# be all the way from the back end over to the front end was web forms, both in ASP.NET Classic and over into ASP.NET Ajax, although that added in a lot more JavaScript, which was needed. Then we had Silverlight. Silverlight was really the best way to kind of do this for a while, where yes, we had a plugin that was needed, which we know Flash, we know now Silverlight. Plugins isn't necessarily the way that we want to go, but the idea was, and Silverlight was originally called WPF Everywhere, so the idea was to take what we know on the desktop and what we're already doing on desktop and within .NET and bringing that over to the client. Silverlight, during its day, was a great platform to build applications on top of. Thanks to HTML5, that whole kind of revolution, we switched over to a lot more JavaScript. Silverlight faded out of favor. But I would say that these are really the first two solid attempts that we had at bringing .NET development into the entire stack of your web applications. Now, what Blazor is, just to have an idea here, so Blazor is a preview .NET Web Framework using C# and HTML that runs in the browser. Now, this slide used to say an experimental framework, but as I would say 3 weeks ago, maybe a month ago, it was officially announced that it was going to drop from experimental into preview, and it's now something that is officially a part of .NET. So you'll actually, and I'll have a couple slides on this, but this is something that has gone beyond just a side project from a couple people over at Microsoft to a very exciting technology that people are actively developing applications on today, even though it's already in preview. Now, some people might wonder why the Blazor name, and the idea is that the browser plus Razor, so the folks used to Razor syntax within ASP.NET MVC and ASP.NET Core, that is what makes Blazor. So that's kind of where the name comes from, just to give everybody an idea. Now, some of the frequently asked questions that I run into when I either talk about Blazor or anybody comes up to me and really chats about Blazor, let's handle a couple of things of what it is and what it isn't. So what it is, it's client-side C#. It's based on web standard technology, so nothing that you'll see in here breaks the web standard in any way. In fact, it's kind of on the cutting edge, but at the same time, it is web standards that we're interacting with. So no plugin, nothing like that, right? It runs on top of WebAssembly. So if this is the first time that you've heard of WebAssembly, essentially think of it as just like assembly is what all programming languages ultimately break down to into the zeros and ones that we're interacting with on a computer. It's the same thing for the web. So it's essentially a lower level language than JavaScript, for example, that browsers can run. Now, the interesting thing about WebAssembly is that as long as you can write something that compiles into WebAssembly, that means that you can target the web with that technology. So Blazor just happens to be what we're talking about today for C#, but there are other libraries out there that use, for example, Rust or C++ or other languages that are traditional server-side languages or technologies that aren't necessarily what we target the web with, that you can actually start using already today to start developing web applications. So WebAssembly is kind of at the heart of this, and so that will come up a couple of times, but I just wanted to kind of level set that for everybody. So it's not JavaScript, it's a kind of a lower level language specifically for the web. Now, it also runs .NET standards, so this isn't anything that's kind of specific, a very narrow down version of .NET or .NET Mini or Micro or anything like that. It's just regular old .NET. And as I mentioned, it's currently in preview. So not experimental, which is exciting, in preview. So what it is not, as I mentioned, it's not a plugin. So everything I talk about here can be executed today in modern browsers. It's not a plugin. If WebAssembly is supported within the browser, it can run anything within Blazor, more or less. It's also not ASP.NET Web Forms. So it's, while we'll see some similarities, it's not necessarily the reinvention of ASP.NET Web Forms in any way. It is, while it's an easy way to transition from maybe Web Forms applications today into something a little bit more modern, it still isn't just Web Forms v. whatever we want to call it, right? It's also not transpiled JavaScript. So one of the most common things that I see when I talk about Blazor is that people assume, well, okay, so you have some interpreter that takes your C#, transpiles it, essentially modifies it, right, goes into a black box, out comes JavaScript or WebAssembly, and that isn't necessarily the case. In fact, when Blazor, and I'll go into this as a client-side and a server-side edition, and when you run it on the client, you're actually sending DLLs over onto the client. And what's really cool, I don't have a demo of this because it takes a while to set up and I still haven't managed to get it to work. I have juggling a couple of too many things, but the folks over at Microsoft do demos where they actually showcase the Chrome developer tools being used to debug C# code on the client. So in the browser, just the same regular edition of the Chrome developer tools you're using today, actually going through and setting up breakpoints in C# code. So essentially, a little addition of .NET Standard is running within the Blazor runtime on the client, and that's what's being used to run the DLLs that you have that are being shipped over when you run on the client side. Now, I don't want to dive too much into like security things around that. Just trust me, it's done in a safe way. But I'll go into a little bit more about what client side versus server side, what that looks like. But I just want to throw that out here. It's not something, a black box that just automatically does work for you. I generally don't like things where automatic things happens because that means I don't have control over it. And that's what's really exciting about Blazor is that we don't have to worry about that happening here. Now, a couple of key differences that I want to bring up between Blazor and, for example, if we're dealing with other modern web development, is, as I mentioned, on the Blazor, right, we're using the .NET standard libraries, nothing crazy there. We're using MS Build, so the actual build process that you have today already within any .NET application. And you're running with C#, right? C# all the way through. Never, I shouldn't say never. You rarely have to touch JavaScript. We can go into some of those details there, but you can get an application up and running without ever touching JavaScript in any way. On the JavaScript side, you do things like, for example, NPM packages. Right, we're used to that. Anybody that's run npm install, or for example, has ever tried to copy and paste a very simple project set up with the Vue, React, or Angular CLI, and it takes forever to move over because you have like hundreds of megabytes of things in the npm modules, and you don't have to deal with that. We also, on the JavaScript side, we use Webpack. That isn't something that we have to worry about on the Blazor side, right? That's all being handled by MS Build, so just as you'll see when I jump into Visual Studio. And then, of course, we deal with JavaScript or TypeScript whenever we work with one of these more modern JavaScript frameworks. So you can kind of see the difference there, right? The whole idea of Blazor isn't to necessarily teach you a whole new technology stack. Yes, it's a different approach to doing web development within the .NET stack, but the idea is to follow along with that stack as much as possible, while potentially, like the list that we have over here for JavaScript, NPM, Webpack, and JavaScript, sometimes I feel like people that are talked to on the .NET side, they will just roll their eyes when they hear those things. And honestly, as somebody that deals a lot with web development, I've tried to do Webpack from the ground up. And each time I fail and say, well, I'm not smart enough to do this, and then I just go with the CLI. So Webpack and all this kind of setup that we have on the web side of things can be kind of complicated, and that tries to be a little bit simplified within Blazor itself. Now, I already covered a little bit about this, but what is WebAssembly? Let's dive a little bit into that as well, just to make sure that we're all clear. So, WebAssembly, or WASM, so you might hear some people say that. Pronouncing acronyms sounds weird, but WASM, that sounds weird. But it's a web standard, as I mentioned, right, that defines an assembly-like format for executable code in web pages. So, ultimately, it's what really makes Blazor even possible. So I have a couple diagrams I'm going to throw up here, and hopefully we can follow through here, right? So on the left-hand side, right, we have our HTML pages and our JavaScript pages when we deal with regular or JavaScript files, I should say, when we deal with regular web applications today, right? HTML, CSS, and JavaScript. So those all come together to form to get inputted into the parser, which creates the overall syntax tree, right? So the syntax tree is essentially just, this is what my application looks like and the interactions that I want to have within the application. Goes through the compiler and then through the just-in-time interpreter. All that kind of combined together is what we have as the JavaScript runtime. So if you don't want to worry too much about parser, compiler, and the JIT interpreter, just think about the fact that HTML and CSS and JavaScript, they all come together, they go through this JavaScript runtime, and out comes the native web APIs that we have today. So for example, just manipulating the DOM, right? Moving something over, adding an element, removing an element, or file storage, or whatever it might be. Now, if we add this, talk about WebAssembly, this is where things get a little bit different, right? So it's still overall the same diagram, right? It's just a WebAssembly goes straight into the interpreter, and then out you get the native web APIs and everything like that. So unlike TypeScript, which essentially is a language that then compiles down into JavaScript that then goes through this, the WebAssembly code is actually compiled into bytecode. So that's ultimately the kind of main difference between something like TypeScript and WebAssembly, where it just goes straight into the interpreter, comes out of bytecode, and it allows us to build JavaScript bytecode with other languages. So as I mentioned, there's already C++ implementations of this, Rust, Go, and now .NET implementations. And really, if there's some programming language that you love that doesn't target the web today, you can already start developing something towards WebAssembly if you got the chops for it. I know I can't, but there's a lot of better developers out there than myself. So you have the ability already today to target WebAssembly, and then WebAssembly will be what takes care of everything for you in terms of getting access, to the native functionality of the browser, etc. And the great thing about WebAssembly is that it's supported in all major browsers, so this isn't necessarily a technology that I have to say, well, you need to go to Chrome Canary, or you need to turn on this flag, or whatever it might be. WebAssembly is alive and kicking, and it's something that's already being used today. Now, how Blazor applications fit into this is there's a couple different things that we have to take a look at here. So one of the main things to think about is that Blazor is really all about the UI, right? I'm talking about C# going from the server all the way into the client, but if we think about Blazor just like we think about Vue, React, Angular, or anything like that, it's just a way of developing the UI of your application. So that means that into what we have here, so instead of just regular WebAssembly, what's in charge and actually makes Blazor work at all is the Mono WebAssembly interpreter. So if we have heard of Mono before, you probably have, but Mono is essentially a framework that helps .NET run on other solutions. So Mono has been around for a while. I remember working with Mono in my web forms days in order to have a way to be able to run ASP.NET web forms applications on Linux servers, for example. But Mono has also been responsible for the success of a lot of other frameworks out there that are cross-compiling, and that also is ultimately what runs the .NET code to translate that then into WebAssembly. So that's why you have mono.wasm. I'm going to keep on using WASM because it's a funny thing to say. Then you also have this interop layer that can communicate with Blazor pages, which can be CS HTML or .razor pages. We'll see what that looks like when I'm in Visual Studio. That then communicate with Blazor and Mono.js. So the reason that we have these is ultimately we are developing web applications, and there are some things that we might have to deal with on the JavaScript side. However, what we can do is we can write what's called an interop. So an interop is essentially a way for you to offer JavaScript functionality in C#. So you can write C# when you're developing against it in Visual Studio or whatever it might be, but you might have to write a little bit of JavaScript in order to be able to kind of handle that. So Blazor and Mono.js, those are just ways to be able to offer some things that we need to really just marshal calls between JavaScript and Blazor, and I should say JavaScript and C#. So that's just there to handle some of those cases. In a lot of cases, you can actually get away with just this stack, right? .NET Standard.dll, your app.dll thrown into mono.wasm. But there are still, in order to make sure that we can develop the full type of applications that we're looking to develop, that interop layer becomes kind of critical. I know that these designs are probably beautiful and everybody's saying, ooh, look at all those rectangles and arrows. But hopefully that gives everybody, and generally I know this is a little bit scary, especially the black box of the parser, compiler, and just-in-time interpreter. Don't worry, there's no quiz at the end. All you really need to understand is kind of get an idea for how this works and why this DLL isn't being transpiled into JavaScript and kind of how it differs from other solutions. So just kind of keep that in mind. Now, let's talk about some Blazor frameworks and what it can provide. So the Blazor framework, first of all, comes with a virtual DOM implementation. So some of you might have already heard me explain this today, but a virtual DOM is essentially what the name gives away. It's a virtual copy of your DOM. Now, if you're not familiar with diving into benchmarks of what it means to modify the DOM, etc., anytime that we're dealing with JavaScript, adding elements to an HTML page, updating HTML elements, removing, whatever it might be, right? If we modify the DOM, that's overall a very expensive thing to do. If I'm, for example, even just a simple input element that as I type in something into the input, something gets outputted at the another part of the page, right? So just a span that has some text in it that's bound to what you're typing in. Every time you type an updated letter in the input and have to update that DOM element, there's an expensive exercise that happens within the browser to go through and understand, okay, you need to access this element, you need to update the element to this, I need to repaint the element, there we go. Oh, you just typed in a new character because you're typing really fast. Well, now I have to go through, have to find the element again. It doesn't necessarily keep that element referenced in any way, so it starts at the top, which is, this is my HTML page, and it goes through the tree, finds that element, updates it, and then it goes away, and then it comes back and does the same thing. So in large applications with many updates, frequent updates, this is very expensive, and ultimately one of the reasons why people started picking up things like Angular, React, or Vue, or now Blazor, because in the jQuery days we were doing this over and over again, and you can see some issues popping up from that. So a virtual DOM, what it does is it keeps all your changes that you do in memory. So if you're just doing one change, that's easy. It says, okay, I did one change in the virtual DOM, and then it reconciles that and looks into the actual DOM and says, hey, out of everything that you have, I only need to update this one element. Well, what if you have a method that does like a for loop, updates a bunch of stuff, calculates new things, adds elements, removes elements, and whatever it might be that you're doing in JavaScript, let's say, or in this case in Blazor. And if you have to do that constantly within the DOM, it would just slow down your application so much. So instead, you now do all these calculations in the virtual DOM. Then once everything is settled, once it's like, okay, buddy, you've done a lot, but now I know what I need to do. It compares it, only the changes that have happened, to the actual DOM, and then goes through and does those updates. Keeping the DOM in memory or virtual is a much quicker interaction, and then going through and just updating single elements as opposed to the entire page multiple times overall speeds up your application. This is why Angular, React, and Vue are so successful, and that's now being brought over into Blazor as well. Now we have the idea of components. So if you're not familiar with that structure, you'll see what this looks like within Visual Studio, but it's very MVVM-like for those of you that are familiar with the MVVM pattern. You have data binding, you have event handling, you even have the concept of layouts. You can do dependency injection, which is a scary word, but it's not that scary. If you're familiar with it, it's not at all, and you're probably already doing dependency injection without knowing it. And then it also has routing, so it can handle users navigating throughout your page. And then it also has a JavaScript and a C# interop, so you can send C# commands into JavaScript and JavaScript commands over to C#. So you can kind of work with it either way. Now, if we take a look at some components, this is actually the very basic layout of a component. We see that up top we have H1 element. We then have that @ symbol, which we'll see everywhere. And then we have a variable called heading text. And then within this statement here, at functions, we see that we have private string heading text, and then we have equals hello world. So we'll see this in Visual Studio, what this looks like. But when you go ahead and type in whatever you do in that heading text is now bound to that variable. And anytime you do that @ symbol, and with that variable, boom, it's available within your application. And this is all contained into one file, by the way. So you can very easily, yes, you can architect it out and have multiple files and then blah, blah, blah. But what's nice is that this will all be available within one single file. No code behind, no other control or anything like that. It's all available on the same page. On the routing side of things, you can do this, for example. So that app page thing, we'll go into that a little bit, but you can do something like app page root parameter, or you can do app page root parameter and then do these little curly braces. Just temporarily lost the word, the most used thing in programming, essentially. So curly braces. And then when you use it, types that in as a parameter into the URL, you can actually get access to that by doing this @text thing in your component, which is pretty neat. And now for a dependency injection, we can take a look at what this looks like. And this is actually taken straight from the Hello World example that comes with Blazor. So we'll see here that we're injecting the HTTP client HTTP. And then a little bit within our function here, we do an await and then so it's an asynchronous function, right? And we do http.get JSON async weather forecast, and then we pass in the URI. So all this is doing is essentially allowing us to now inject an ability to do HTTP requests back and forth in our component just by doing this @inject command. So it's not something that's available out of the box within every single component constantly. You're going to do these @inject, @page, @add, whatever it might be in order to be able to add functionality into each individual component, but it's super easy to get up and running with and get started with. Now, some prerequisites that you need. So you need to have .NET Core 3.0, the preview SDK installed, which is currently in preview 5. Just got announced this week. I had this demo up and running on preview 4, tried to run it. It said, you need to upgrade to 5. So you need to be on the latest and greatest within ASP.NET Core to run this. You need to have Visual Studio 2019 at least 16.2 installed. It's a little bit easier right now to be on the preview version of Visual Studio, so that's why I have this little option down here, or optional. If you're using a non-preview version of Visual Studio 2019, then you need to go in and enable preview SDKs, like I have set up here. This is all available on the Getting Started resources for Blazor, by the way. So when you go over to their website, you have this. This isn't the only resource for that. I would just recommend, if you have the option to, run with a preview version of Visual Studio, because they'll be updating that a lot quicker than the main branch. And Blazor's moving at a fast speed, as is ASP.NET Core. So it's just a little bit easier to keep up with the latest and greatest. Now within File New Project, what this looks like is you have the ability to do Blazor client-side, Blazor ASP.NET Core hosted, or Blazor server-side. I put AKA Razor Components here because Razor Components has been the name for a while. However, what's a Razor component? What's Razor syntax? What's a Razor page? Razor's everywhere within ASP.NET, especially within ASP.NET Core. So there's currently an effort right now to rename these into Blazor components, so you know that you're implementing a Blazor component as opposed to implementing a Razor component. I'm sorry that I'm confusing you with throwing out Blazor and Razor. That's just the way it is. But if you see any references to Razor components, not Razor pages, that's actually Blazor running on the server side. So what does this all look like? Let's jump into a demo here, because I have about 18 minutes or so of your time. So let's see what this looks like. Let's actually start fresh. Let's open up a new version of Visual Studio. Let's create a new project, and I have a cheat application there in the background. Hopefully nobody is upset at me at that. Oh, you can't see my screen. Look at that. You know what's really interesting is how this goes back and forth. Thank you for letting me know. I'm going to unplug it and plug it back in. Did you restart it? That's always my favorite question. And you still can't see it. Hold on. I can fix this. This is... Or not. Where did that go? Come on. This is, of course, the demo gods coming at me for... There we go. Yeah, okay, for some reason, Windows key P went away and didn't want to come back, so there we go. All right, now that I've sacrificed the proper go to the demo gods, I'm going to select an ASP.NET web application. Actually, it should be an ASP.NET Core application. Where are we at here? There we go. Let's just do that. So I'm going to call this Progress Next Awesome Blazor. There we go. Go ahead and hit create. Now we'll think. And now we see here, because I've installed Blazor, we got Blazor server side, we got Blazor ASP.NET Core hosted, and Blazor client side. For this demo, I'm just going to do Blazor server side so we can take a look at what that looks like. It's more or less the same thing, though, overall. I don't want to dive too much into showing, because I don't have time, just how you can go from client to server, but actually they're setting up in such a way that it's just a single configuration option. You can go from running server-side Blazor over to running client-side. But if we take a look at a page here, app.razor doesn't tell us anything. But let's actually dive into the pages here, and let's take a look at what index.razor looks like. Thrilling. At page, just a single slash, nothing in here, right? Nothing too crazy. But if I run the application, let me just show you what this looks like. What we're going to see is just how this is essentially a quick application with a menu navigation over on the left-hand side that allows us to actually click around within the application. So you can see here we got a weather forecast, we got a counter. Again, click on that button, which is like super thrilling, right? But let's see how all this comes together. So when I went to home, I just had slash hello world, welcome to new app. So that's what we saw. But let's take a look at something like the counter. So if I look into the counter.razor, now we're seeing things that are a little bit more interesting. Now we're cooking with gas here. So what we'll see is, first of all, we have the app page / counter. So this is what I was talking about with routing, right? Up here, you can define exactly the route to get to this particular page just by declaring app page. So this means now that even if I don't have a navigation to it, I can purposefully put people there if I want to using that URL. Now we see that I have a variable called current count, and which has this little funny app thing, right? And down here, we can see that we have current count. So this is originally set to 0, which when I clicked on that button, right, that was originally set to 0. Now here we have on click, and we do @increment count. We have a function down here within this app functions area that allows me to say, all right, so every time I click on this, I'm going to current count ++. So that's essentially the code behind the counter. I know a counter isn't too thrilling, but what we should keep in mind here, right, is that just by declaring app functions, this is .NET code. I have a variable called int that I can access. I can, called current code that is an int, and I can plus it, just increment it within my increment count. And it's very similar to how you might already be dealing with JavaScript today. You declare a variable, you say, hey, this is what I want to bind to using the @ symbol, and then you can work with an onClick event in order to be able to attach to a C# function that's being executed. So if I wanted to now go ahead and add this counter into my main page, I could actually do something like this. And we'll see now that we get this little @ symbol next to it, which indicates that it's a Blazor component. And I can just click on that, and we now have autocomplete for that particular component. So if I refresh the application, and I launch it again, we'll now see that on the main page, what's happening is that I have the counter down here, right? So we still see counter, current count, and then I go and just hit +++++, and then we'll see here that there's separate instances on each page. So right now I'm not saving any data locally, or even saving any when I'm switching between them. But the idea here now, right, is that I created a simple counter. I already had it within the application, and instead of having it as a separate page, I can now automatically include that as a component using essentially an HTML syntax within my other pages. Now, let's take this to the next level. And just from the sake of time, what I'm going to do is open up another project that I have running. Let me close this so I don't get yelled at by Visual Studio. Ooh, now I'm just locking everything up. All right, oof, sorry. All right, so let's jump in here. So I have a couple different pages that I want to take a look at. But one of them is jumping back into the counter. I don't want to do any of that. Thank you. So this is the exact same code, except now I have what's called a parameter that I declared using attributes within C# that I'm calling increment count. And then down below, I say, okay, with the increment count, what we're going to do is originally set to 1. So if I don't pass anything in, it's when I click on that button, it's just going to add 1 each time. But now, because I'm adding this parameter, I can now pass in, because this is a getter and a setter, I can now pass in this value into this component and increment it with whatever I want. So for example, I've already done this here, but let me just show you what this looks like, because it's a little bit magical. So I have the same counter, right? And as soon as I get IntelliSense that pops up, check this out, right? Increment amount is right there. It might be a little bit hard to see, so let me just select it and add it in. And then it automatically knows that I need to pass something in here. So if I just, for example, throw this in, it should give me an error. It's not giving me an error. There we go. So it knows that I can't just toss in anything into it. So if I want to make this 100, hit save. We now see, okay, there's no squiggly lines, there's nothing wrong with this. It automatically knows that this needs to be an int because I defined it as an int within the other component. Now when I run this, I have this habit of always going to the solution because of old habits die hard. It used to be the only way you can do things in MVC. That's just my own habits. I need to get out. It's much easier now. But anyways, now when I click on the counter, we'll see now that it increments by 100 instead. So this is just to give you like a little bit of an idea of the power of what you can start doing. So this is, if you've done any modern JavaScript development, this is very similar in terms of how you can define a component as a small building block, then add to that by having composite components built up of other components, and you can start transferring data back and forth utilizing something like what we have here. For example, on the fetch data side, we'll also see that this is even, this is something again that comes out from out of the box. We see that there's actually, you're loading forecasts, and it starts off by having if forecast equals null, you can actually provide an if statement to detect when you need to show a loading message. And then from there, once that flips over and you have some forecast, it'll then go through and it'll put out everything within your forecast object here, and you can set up a for loop, so for each of forecast and forecast. And here you have, again, strongly typed, and you have the ability to also work with IntelliSense to be able to grab all the fields off of your objects. So if I scroll down here, we can see that we have a type weather forecast that we can go into if we want to dive into our data folder here, where we see that we have a date, temperature C, temperature F, and summary. And that's something that we can all access immediately here from one single component. So again, so something that previously, in order to get your model and have that transfer over into the client side, you have to define the model strictly within C#, add essentially all the attributes that you want to in order to make sure that the model has what it needs, right? And then when you do it on the client side, you then have to redo it all over again in order to create a strongly typed model. In fact, that's something that we tried to solve with the jQuery components to allow you to repopulate the model. Now, it's all there available within your page, just within the declarative markup that you have. That's just using regular HTML, once in a while throwing in maybe another custom Blazor component or Razor component, and it's just right there. That's the coolest thing about this, especially somebody who used to do a lot of web forms development, is that my model, everything I do on the server side, is just automatically available for me there. And all that I need to do to throw this in is just within this app functions. We can now see how we can start creating a data layer that's separate, that's not necessarily a part of the component. Just import my model, hydrate that model in an array that we might need, and then start working with it within my application. Now, I want to jump back just quickly. Not only am I running out of time, I think I'm running out of voice. So if I just start wheezing towards the end here, I wanted to mention a couple different things between Blazor client-side and server-side to give you some insight here. So as I mentioned, right, Blazor by itself, so on the client side, you have the browser, you got the UI thread, and then you have Blazor. It's essentially all living on the client. So as I mentioned, your assemblies actually gets shipped over to the client when you're starting the application. Now, in today's world, client side is a little bit slow because you have to push everything over into the client. You have to load everything. So anything that's based on client side Blazor has an initial long load time because you have to download anything. We're talking about megabytes at this point, right? Kind of crazy coming from JavaScript where we're trying to minimize down into kilobytes. But anyways, that's kind of where we are today. This is being improved. As Mono improves, as MonoWASM improves, as we continue to figure out ways to essentially do tree shaking within Blazor, which there's already some implementation of, it's just getting better. This is essentially what Blazor is going to be. I don't know when, if it's a year from now, 2 years from now, but ultimately it's just going to be like Angular, React, Vue. Now you can just pick C# and it's going to all run on the client. But you also have today's implementation of Razor components, which you displayed in the browser, and what I was showing you was exactly this. But then on the server, you have the .NET.exe, and you have your ASP.NET Core, and within ASP.NET Core, you host these Blazor components, and then SignalR is what's responsible for sending those components back and forth. So when we initially load the component, SignalR sets up a connection, ships over the HTML that you need for that component. It takes care of everything on the server side. So you can think about this as server-side rendering, essentially. Then when we do an update, we say, hey, SignalR, I need to update something like that increment count. What am I supposed to do? It goes back to the server and it's like, I know, here you go. Here's the next piece of like DOM that you need to update. That virtual DOM, those differences that we're talking about, that's kind of what gets sent back and forth over the wire. So it relies on SignalR. So there's a couple of drawbacks of that, like if you're developing an offline application or if you're don't have a steady connection constantly, it can be a little bit iffy. However, that's also being improved. They're doing a ton of work on trying to figure out how to make this aspect work even better. But what's really cool is that this is going to ship with ASP.NET Core 3.0. So this is officially a part of ASP.NET Core. So once 3.0 is official, we're in Preview 5 now, right? And once it's official, which should be later this year, you'll already be able to use Razor components. And we have a lot of our existing customers that are actively targeting Blazor already today. They're building applications. In fact, I know of 2 startups that have done everything on Blazor now. Now, this also can potentially open up the idea for us to potentially run Blazor on the desktop. So thanks to Electron being able to have something that allows us to run web applications on the desktop, through Mono and the same kind of interpreter, WebAssembly and everything like that, we can now potentially create a project that can run on web, can of course be responsive on the web, and then it might even be able to be run on the desktop. So we can start developing these truly universal applications. Now this is just out there right now. This isn't something that I would say, yeah, develop your next application on this, but the project is already there. People are actively working on it to make this even better. And it just opens up, and I included it here just to give you an idea of that it opens up even more opportunity for us to be able to develop applications with Blazor. It might not just be web applications. It might be the next desktop or universal application, whatever you want to call it, which is pretty exciting. Now, I got about 4 minutes left of your time, so what I just wanted to cover at a quick high level is actually Telerik UI for Blazor, because what we have right now for Blazor is a set of essentially community-supported components out there to start developing some of these applications. You can build something from the ground up on your own. It's just using HTML and C#. That's really all that we're doing. But we're talking about a lot of different UI components. So what about if we need something that's a little bit more advanced, like a grid or charts or whatever it might be, especially if you get all excited about Blazor after today's talk and you want to go out and develop an application. Well, this is where Telerik UI for Blazor comes in. So, Telerik UI for Blazor, for those of you that were in my What's New in R2 talk, you've seen this, but it's a brand new set of UI components built from the ground up for Blazor. First line of code is written specifically for Blazor, and it's native to Blazor. There's no jQuery, there's no JavaScript under the hood, 100% Blazor. So you're using C# instead of JavaScript to develop your web applications. And UI for Blazor has actually been available as an experimental set of components since January. So when Blazor was experimental, we were experimental. They dropped and became an early preview. And since then, last week on Thursday, we dropped 1.0.0 of Telerik UI for Blazor, which is pretty neat. Now, this initial set of components, 16 components, the grid being one of the main ones. We got form elements, so text boxes, date pickers, drop downs, essentially anything you need to create a form either within the grid or externally from the grid. We also have charts enabled and a ton more. So while there are some things under the hood that deal a little bit, we have a couple pieces of interop that happen here and there. Generally, it's all just C# that you're running. And this is why we only have 16 components when you compare it to like the 70 components that we have within, let's say, jQuery, for example. But we're doing this the right way. We decided that we want to build something from the ground up because that allows us to integrate into things like the validation framework that Blazor offers. We can automatically validate with the data model that you define without doing anything additional. If you set up validation messages on your model, automatically will pop up in our components. And we work with templates, so that means that if you want to define your own custom template within our component that uses Blazor, automatically work with that. There's no kind of workaround. So we're quickly expanding the list of components. And I do have the same project that we were talking about before, showcasing before. I just wanted to, let's see if we can jump over. Where was I? Where am I? There we go. Let me just run this. So we actually have a couple of our Telerik components running here, and I know it's the last session. I got a minute left, but for those of you that want to hang around just for a couple more minutes, we can see here that we actually have a grid. It's up and running, has two very thrilling fields, ID and the name, and then a Telerik button. Woo! Things are happening. Nothing happens when I click on it, though. But if I go back into my project and check out the Telerik sample here, for example, all that we're doing is that within this app functions, we're defining IEnumerable that just has ID and the name. That's why it's very thrilling. ID is equal to X. X is going from 0 to 49, or 1 to 50, sorry. And then the name is just the name plus that variable. Don't worry too much about that. But if we check this out within our markup here, we see that the Telerik button, for example, is just as easy, again, as saying Telerik, and then button will automatically pop up. We see here that we have a couple of other things that we can work with, but we don't have to worry about that. It gives us some intelligence there. For the grid, notice how I pass in at my data, which is the same thing that I have in my function here. And through that, we can actually automatically start working with my data and just define the fields that we want to work with in order to be able to display the component like we have here. We can even take it a step further and offer editing, which right now looks a little bit crazy. But you can see here that what I wanted to showcase just through this is that in the Telerik grid columns, you can even do something like this. For example, name of sample data.id, if you wanted to ensure that the property that you're accessing isn't just you typing something out and is indeed strongly typed for the particular model that you're dealing with. And then this has code that goes into it. I don't want to scare anybody off from that. But what I wanted to highlight, just for the sake of time, is that if you go to demos.telerik.com, you'll be able to see this. We also have a ton of documentation, but this is a full list of the components that we have available for Blazor. This application is actually built on Blazor. So this demo application that I'm going to be clicking through, that showcases all the components. Like, for example, if I wanted to go into and check out this editing thing, I could do that. I believe if I do this, we'll see. Nope. We didn't build in validation into this demo, but you can see that it's very easy to just go with a regular interactivity that we see in a lot of grids. We can do filtering, sorting, and paging. And the craziest thing is that I'm on conference Wi-Fi, and I'm still able to do this, even though this is a server-side application. So this kind of also gives an indication that there are professionally run applications out there that are built using Blazor and using the server-side. So anyways, if you're interested in that, interested in Blazor and adding some more UI components into this, it's a great set of components. I'm very biased, so I'll just give that statement out loud, but it's there for you to take advantage of. But the main purpose of this talk was for you to take a look at what Blazor is. So that leaves me now with just 2 minutes over the limit here, and we'll end with some Q&A. And again, thank you so much for coming and attending the talk. So everybody here seemed more or less attentive, so a lot of head nodding. Nobody like jumped up and went, yeah, or nobody flipped the bird and said, yeah, F you, JavaScript. So at least we have a civil crowd, but you never know. I've had some people share some pretty vulgar language with me about their JavaScript development efforts. But anyways, I can be found at birmingham@progress.com, not at email.com. And then we have, you can find me at Carl Bergenham and at Carl Bergenham, both on LinkedIn and Twitter. But if you actually do Bergenham@progress.com, again, somebody really, me, should be going through these slides in more detail. But that's what I get for copying and pasting unfinished slides around. But anyways, you can reach out to me, Bergenham@progress, and we can talk about Blazor. So thank you, everybody, not only for this session, but attending Progress Next as a whole. And I'll be here for any questions that we might have. So thank you again. All right, any questions about Blazor? Yes?
So you mentioned dependency injection. Is that like way you support interfaces? Or you could, I guess, how does the dependency injection work?
So when it comes to interfaces, I believe that you can work with that, actually. So I'll be honest and say that I only know the dependency injection part at a high level. Just how deep it goes with existing dependency injection that we might see within .NET. I wouldn't be too familiar with that. I know enough about Blazor to be dangerous and develop some applications. I haven't gone to that level yet. But I haven't seen anything that would indicate that interfaces would be out of the question for something like Blazor. Yes, a question in the back. So where I'll be publishing the PowerPoint presentation, I believe will be on Progress Next on the website. We'll like tweet out about it as well, so everything should be up there. And I'll fix this last slide with my real email this time. Yeah. But the recording should also be up, so if you want to hear what I sound like with a slight cold over and over again, we can rewatch the session together. Any other questions? Yes? Caching, that is a great question that I'm not 100% sure of, actually. Caching, when it comes to things like, for example, styling, so like CSS and everything like that, that's handled the same way. In fact, I didn't show this with our components, but you still include a CSS file like that, right? And when it comes to caching of the actual bits being sent over, I believe that when you're doing server-side Blazor, because most of it, all of it is more or less handled on the server and the communication is going back and forth there, you don't need to worry too much about caching. And when it comes to the client side, not sure if the caching is already taken care of by the fact that it's already loaded on the client, right? And at that point, what additional kind of caching do you need? So that's a long answer for I'm not sure, but it's a good question.
But on the client side, we have the initial DLL.
Yes, exactly. The initial DLL is there, which is why right now it has a larger load. So we actually originally shipped our sample application, and that was client side. But one of the initial things was people were like, listen, it takes too long to load. I want to get into the samples, and we want to see what Blazor can do. So we switch over to server side. So right now, what's being shipped with ASP.NET Core is specifically focused on the server side components. And then as the client side version of Blazor improves, more and more emphasis will be focused towards that. So that part will still be in preview as they continue to build it out before they feel perfectly confident that they have everything that they might need for client-side Blazor and have the performance where they need it.
I got a bit confused about the query string, how the task query string from the browser client side.
Oh. Yeah, so that actually happens to be in one of the slides that I have here, just a very basic example. So if you pop over here, essentially what we're doing is just by defining that parameter in your page here, by saying root parameter and then text, it gives you the ability to grab that variable from this particular page. So that means that because you're defining a page in here, you already know what the page is, and if you want to have a longer query string, you can define whatever comes next. Those are my parameters. You get that as a string, and then you can just go through and parse through that and do whatever you need to do. Or you can continue to like chain slash this slash and then grab the variables that way as well. Yes, in the back. Mm-hmm.
People who work on both sides. What drove the decision for Microsoft to kind of jumble it all back into the same place again? Because it seems like when we used to do ASP back,
Yep. Yeah.
It seems like it's trying to go back in that direction. So what drove that decision?
So this is just kind of paraphrasing from listening to a couple of Daniel Roth's talks on WebAssembly. On Blazor, which uses WebAssembly, and I almost said WebForms as well, but he's the product manager for ASP.NET, and specifically, Blazor is one of the hottest things for him, right? What I've heard him say is essentially that he misses like the tooling that was available in the WebForms days, right? I mean, maybe not. We probably won't get down to the level of dragging and dropping onto the designer, but everything that you needed to develop WebForms applications was right there. The technology stack, everything you needed was within Visual Studio. Yes, you had the drag and drop designer, you had some easy ways to set things up, but everything was just there. You didn't need to then go out and say, hey, other team, could you set up the backend for me? Which some people still did, right? Or hey, other team, can you write just the backend for my application while I focus on the client side? So I believe that the shift into having different people work on different things. We still have full stack developers, right, that do everything. But I believe that shift just happened out of necessity because we were doing everything now on the client. So we essentially went from only server side. Now we were on only client side. And then people said, hey, we also, like, just loading everything in the client isn't good because we need to mix and match a little bit between server side rendering, doing some pre-renders, like being inventive with how we can develop applications for the client side while just serving whatever we need. And when we had that separation, it just became, well, you need to learn JavaScript. And then you might have some people that are better at JavaScript than C#, for example. And then you had frameworks like AngularJS, React, Angular, Vue, and everything else, right, that started coming out that, okay, now you can identify yourself as a React developer as opposed to just a JavaScript developer. So there's just too many skill sets out there, right? And this still provides you with that separation. The idea of components, yes, it can be seen as controls of the past, but it's still, we developed a lot of controls, but not a lot of people were thinking about their application as a kind of standalone components. And when you start bringing that component architecture that's so popular in modern JavaScript development today over into C#, right, you can now bring those technologies together, avoid the spaghetti code of the past. You can still write terrible components. Listen, give me any project, I can ruin it with my code, right? But the idea, right, is to converge those technologies, again, so that you don't have to necessarily have separate front-end teams, back-end teams. You still might, but you don't necessarily have to do that, and you can have teams that have full-stack developers and that truly use the same technology from start to end. And it's just all available in this more modern kind of setup. So it's a very long answer for your question, but that essentially is, I think, the reasoning behind this, right? I'm bringing that back to what we used to do, but not bring back any of the nightmares, any of the heavy stuff, let's say, of bringing everything over from web forms and doing stateful web that way, and just thinking about things in a more modern way, but for C# or right now C# developers, but I should just say .NET developers in general. Perfect. Any other questions? No. All right, thank you, everybody. Most of you actually stuck around an extra 11 minutes on the last day, so I appreciate it. Thank you so much.